In this video, we are discussing locus of points, and we'll be getting equations of the locus of points. Find the equation of the locus of points which is equidistant from the point A and point B. So when we talk about the locus of a point which is equidistant from 2 points, we are talking about a line which is the perpendicular bisector of that line. But in this video, we are not here to draw the line or anything. We are just here to get the equation of that line which is equidistant from these 2 points. Okay, so how do we do that? Let's first write out the parameters we have. We have point A, which is 2, 3, and we have point B, which is 4, 5. And let's call that point, right? That point having x, y, because it could be any point. All we know is that that point is always at equal distance between A and B. So if this was A, if this was B, that point could be anywhere along this line in between them. So if the point is here, it's at equal distance to. So if this is B and this is A and this is B, if the point is here, it's always at an equal distance to this point. Even if the point is here, like the midpoint of A and B is still at equal distance between the 2 points. So now, to get the equation of this point, what we have to do is, since it's always at equal distance between these 2 points, what we do is we are going to say that the distance between A and P, that is, the distance between A and P is equal to the distance between P and B. So distance of A, P is equal to distance of B, P, right? Okay. So we know that the equation for distance between 2 points is equal to the square root of x2 minus x1 plus that squared plus y2 minus y1 squared. So the square root of that. That means if we square both sides, that's the distance squared is equal to this squared plus this squared. Now we want to say that this distance is equal to this distance. So the distance squared is equal to this squared plus this squared. Now let's write out this equation for both sides. So if this is point B, that is our y2, x2, y2. So y, do I start with y? I should have started with x, but no problem. So y minus the y of A, right, squared, plus x minus is equal to, so for point B, we have, let me start with x this time as it should be, though it doesn't matter, it's plus, it's commutative, anyone that comes first, it doesn't matter, you still get the same result at the end of the day. So x minus the x for B plus y minus 5. Okay, let's expand the brackets. And in expanding, there is an easy way, quick way of expanding. So y squared 2 times minus 3 times y is minus 6y, and then minus 3 squared is plus 9. Bring down this plus, and then x squared 2 times minus 2 times x is minus 4x, and then minus 2 squared is plus 4 is equal to x squared minus 8x, so in that manner, and then plus 16, we bring down this plus y squared minus 10y, and then plus 25. Okay, before we start collecting like terms on one side, because we are going to leave this in the standard form of equations in which everything is equated to 0, whatever thing we see on this side and see it on this side, they will eventually cancel out. Because if we are to collect the items of y on this side, then y squared, and then this is plus y on this side. When it comes over, it's going to be minus y. So y squared minus y squared. So since they are exactly the same thing, they cancel out. So let us now bring in what we have left. We have minus 4x. Let me collect the x terms first. So we've taken away this. And then on this side, minus 8x comes to be plus 8x. Okay, so we've taken out all the x values. Then let's get into the y values. We have minus 6y on this side. And then on this side, minus 10y becomes plus 10y. And then let's take in our constants. On this side, we have plus 9 plus 4, right? And then on this side, we have, it's going to come over to be minus 16, right? And then minus 25 equal to 0. So let's get all that together. We have minus 4 plus 8 is equal to 4x. And then minus 6, we have plus 4y. Okay, 9 plus 4, that is 13. 13 minus 16. That's minus 3, and then minus 3 minus 25 giving us minus 28 equal to 0. Okay, this is what our equation is reduced to, but we can as well reduce this. 4 can go all through. We divide every single term by 4. We'll get that x plus y minus 7 equal to 0. So this is the equation of that point when we started this diagram. So this is the equation of that line that is equidistant from these 2 points. Now let's also see this other question. We have a point moves so that its distance from the origin is twice its distance from the point, 3, 2. Show that the locus is a circle. Okay, so we are to get the equation of the locus of that point. Now let us understand our question. This point we are going to call it point A. So let's say point A is 3, 2. And then a point moves. That point that moves, let's just call it P. P for point. So X, Y. It could be, since it moves, so it could take off any value. And then a point moves so that its distance from the origin. So this is origin. Origin is always 0, 0. So its distance from the origin is twice the distance from the point. So since we've named the 3 points talked about here, we have that its distance from the origin is twice its distance from this point that we've named A. So distance from origin is OP. So we have that OP, right, is equal to 2 times the distance between that point and A. So AP. So this is the equation that we are going to be using to get the equation of this point that moves this way. Okay, so we've already gotten the coordinates of the points. Then we now, the distance OP, that is x minus 0, x minus 0 squared plus y minus 0 squared is equal to 2 of, now let's have this bracket that represents this distance. That is x minus 3 squared plus y minus 2 squared. Okay, x minus 0, that is x squared plus y squared is equal to 2 into, here, let's now expand these points. We have x squared minus 6x plus 9. Then we bring down this plus y squared minus 4y plus 4. Now let's open up this bracket. Is equal to 2x squared minus 12x plus, or should we have gathered this together? Doesn't matter now. Plus 18 plus 2y squared minus 8y plus 8. So that's equal to x squared plus y squared. Okay, so let us collect like terms. I'll prefer to collect all the terms here since we have the squares. Bigger on this side, we have 2x squared minus x squared, and then plus 2y squared, then minus y squared. That's the y comes over to be a negative. It's then let's collect the value in x, minus 12x, the value in y, minus 8y. So let's cancel out the ones we've collected. Okay, so we now have the constants. 8 plus 18, that is 26. Okay, and that should be equal to 0 this time. So we have x minus x squared is x squared, 2y minus, that is 2x minus x squared is x squared, just one of it, plus y squared remaining, and then minus 12x minus 8y, and then plus 26 equal to 0. So this is the equation of that circle that makes this. So if we look at this forms the equation of a circle. Now before we go, let us also solve this so we can actually prove that we've mastered what we just learned. A is the point, this, and B is this point. A point B moves in the plane such that the distance between, that is this distance AP squared plus the distance BP squared is equal to 28. Obtain the equation of the locus of P. Okay, so from what we've learned so far, let us write out our points. Point A is 3, minus 1, and point B is 5, 3. And then we have point B, which can take up any coordinate point because it's a moving point. And then this is the equation of the relationship between their distances. To obtain the equation of this, so we already know how to get the distance AP. So meaning that every term in P will subtract this. We have x minus 3 squared plus y minus 1. That becomes a plus 1 squared. And then this is for AP, right? Then we bring down this plus. Then for BP, we have x minus 5 squared plus y minus 3 squared is equal to 28 according to the equation. Now let's expand all this. We have x squared minus 6, that is 2 times minus 3 times x, minus 6x. This is the quickest way of expanding brackets. But you can go ahead and use any method you know. Y squared plus 2y plus 1 plus x squared minus 10x plus 25 plus y squared minus 6y plus 9 equal to 28. We now collect all the like terms. This x squared plus this x squared, that gives us 2x squared. Then this y squared plus this y squared, that gives us 2y squared. Then let us collect the terms in x. Minus 6x and then minus 10x, that gives us minus 16x. Then let's collect the terms in y before we now collect our constants on one side. We have 2y minus 6y is going to give us minus 4y. Then the constants, 9 plus 1, that is 10. And then 10 plus 9 is 19, is equal to 28 minus 19. Let's collect it on this side. Now 28 minus 19. Oh, there is one more value we didn't collect. That's this 25. That makes it 28 minus 19 minus 25. 28 minus 25, that is 3. Minus 19 plus 3, that is equal to minus 16. So let's collect it back on this side. Okay, so what we have left is 2x squared plus 2y squared minus 16x minus 4y. Then the 16 comes over to be a plus 16 is equal to 0. Now 2 can divide all through. We have that the equation remaining is this minus 8x minus 2y plus 8 is equal to 0. So this is that equation of the locus of P. And this is also the equation of a circle. So with this, we've learned how to get the equation of locus of points. It's basically all about distances.